Hello. So this time we are going to review the concept of normal modes or mode shapes for two degree of freedom system, and subsequently we are also moving on to multi-degree of freedom system. Now I've got with me this very good app simulation for normal modes. So you can find this online with the keyword of PHET normal modes. You can Google it, and you know this is a kind of applet. You need to enable um, your Java, and then you can play around with, for instance, this number of masses. You can start with one and move on to two, three, and so on, but let's now stick to the sample of two masses. So we have these two masses connected with three springs, as is the case of, the common case of two master system. Now, we can, you know, bear in mind that this is the case of two degree of freedom system. And of course, because we have two masses, we are going to have two normal modes corresponding to two different frequencies. All right. So in theory, we could derive all these equations from the equations of motion, and we arrive to two normal modes. The first one is this omega 1 is square root of k over m, or just 1 omega. And then the second normal mode, it happens at omega 2 of square root of 3 of k square root of k over m. So that's why for this case, of two masses, we can have two normal mode with two different frequencies given here. So in this app, we can try to make this thing move by two ways. First is, now of course, bear in mind that this is the case of free vibration. So we need to give an external excitation. Say for an example, we can give this initial position. Say, we can pull this here a little bit to the right. So this is the initial positions given to this system of two degree of freedom, and then we can start the simulation. So we can observe that the response, the movement of this mass 1 and mass 2 is a little bit of combination of normal mode 1 and 2 given here. So the amplitude, this much amplitude of normal mode 1 and this much amplitude of normal mode 2, and they're combined together to make this kind of motion. Now, of course, this is the first way we make this thing move. We can also try to see how is the movement of the each of the normal mode is. So let's go back to zero positions. We can try to see, say for instance, so this should be the normal mode 1. So I'm going to set the amplitude to 100%, and then the normal mode 2, I'm going to make this stay at 0. So here, by this way, we can have, when I hit this start button, we can see the first normal mode of motion. This is the first normal mode for two degree of freedom system. So you see that this is as explained, and as you can also find in textbook and also in my lecture note, that this is the first type of motion in which the middle spring is never stretched or contracted, and then the two masses are really synchronized. They move to the left and right um, together. All right, so this is it, the first normal mode, and we can also check the second normal mode. So let me hit the stop button, go back to zero positions, and now let me set the amplitude of normal mode 2 to 100% and normal mode 1 at 0%. So let's see what it's gonna look like. So this is it. This is the second normal mode. So in which they are in opposite phase. You know, the mass 1 and mass 2, they are moving oppositely, opposite phase. So here it is. You can try to observe this app and learn along the way all things related to the concept of normal modes as well as the multi-degree of freedom system. So of course, this is a very interesting app. You can try to so let me hit these zero positions back again. You can try to give initial position, sufficiently to, because by right, if you want to if you want this system to move with second normal mode, for instance, you need to give a suitable initial position. Say, you can try to make a guess or educated guess. Say, for instance, I don't know, probably somewhere here, and then your mass one also needs to be at this position. See, when you give this type of initial position, it is certain that the normal mode number two will be excited. Okay, so by this way, you can try to make a guess as well what kind of initial position will correspond to which normal mode. So moving on, you can try to increase the number of masses to 3, and then correspondingly you can see in which frequency which normal mode will occur in this particular system. Normal mode 1 is at 0.77 omega, and subsequently 1.41 omega will excite this normal mode 2, etc. So you see, by the same method, you can check, say for instance, you want to see how is the movement of the normal mode 2. So you just need to set this to 100%, the amplitude to 100%, and then you hit the start button, and then you see this type of motion for 3 degree of freedom system. And of course, you can go on and on until, so in this app, it gives you the simulation of up until 10 degree of freedom system, and you can see and learn along the way. You can also try different polarization control. You can hit this button, and now the movement of the mass, instead of going left and right, now it is going up and down. So you see, for instance, I'm going this initial position, so it's gonna look like this. But essentially, it is the same thing as the left and right motion. And another thing, you can also move on to two dimension system, but this is too complicated. You never do this in theory usually, the two-dimension system, but this app or simulation will give you a very nice way of seeing what will happen in the case of two-dimension system. All right, that's it. Thank you.